All right, students. So previously, we have actually seen on how do we handle missing values and also invalid values, and then we have also seen on how to do the data mapping. So in the next subtopic, we are going to look at. Let me just enlarge this a little bit. Let's see. We are going to look at discretization and also binning. So sometimes when we have a large data, what we want to do is we will try to transform this into discrete categories so that it can actually help with our analysis. Uh, for example, let's say if you have a simple uh, data of like your grades, a simple example, your grade, you can actually do the discretization and also the binning, right? So for example, um, 85 90 to 100 is actually A plus, and 80 to 89 is A, and then 75 to 79 is A minus. So like that, what we are doing is we are actually dividing the range of that particular value into relatively smaller intervals or categories, right? In this case, the example is your grade, and this actually helps us to discover the statistics within each interval. So that's your grade is one example. So let's say if we are actually gathering data from an experimental study. So let's actually create a list. Maybe we call it as readings. So assuming that you are gathering some value, but since we don't have that value, so what we're going to do is we are going to use the NumPy uh, library, and we're going to create random integer. We want the values to start from 1 to 100, and we only want 20 readings. So let's do this. Oh, sorry. Let's try to view the readings. Okay. So here we actually have a value, right? 20. This is, we are actually just creating a series data structure. So we can actually find that the range of this particular data varies from 1 to 100. So therefore, what we can actually do is we can actually uniformly divide this interval. So maybe we can divide it into 4 equal parts. So for example, maybe the first bin maybe contains value from 0 to 25, second one 26 to 50, the third 51 to 75, and the last one maybe 76 to 100. So just how we can actually divide a range of data into 4 equal bins. Not necessarily it has to be 4, but just for the sake of example. So what we're going to do is we are going to establish the bin. So here we have defined the bins, right? Each bin. What is the range for each bins? So what we're going to do is let us actually define the bins. So this bins is actually we're going to create a list of the starting and also the ending value, 50, because just now we actually set the range from 0 to 25, then we set it to 50, then 75, and then 100. So we're going to use these bins, and we're going to use a function known as cut. So this cut function requires 2 input. So yeah, we're going to use the function cut. So it requires 2 input, which is the reading, which is the entire data, and also the bins. So these bins will actually determine the 4 equal parts or 4 equal bins. So that's why we actually establishing the starting and ending of each bin. So only for the first one we need to define the start and the end, and the others we just need to define the end is sufficient. So let us actually create that. Let's say we're going to create a category, right? So my category. So we are going to use the panda cut function, and this one requires 2 input. One is readings and the other one is the bins. We need to provide the bins. So when we actually do that, let's view it. My category bins, it says not defined. What did I do here? Okay, I didn't run this, that's why. So I have to execute this, then only we will execute this. Okay, so when we actually do this, we can actually see that we get 4 categories, right, or intervals. And we actually, this is actually when we run the function cut. So we get the range from 0 to 25. This is the, sorry, here. We get actually four categories, 4 intervals, sorry, four categories or 4 interval. And this is actually the, each category, when you see this bracket. So this bracket means this is actually as the lower limit and also the upper limit. So in the case of whenever you see this bracket, so this bracket means the value is excluded. That means the value 0 is not included in the range. And when you see the square bracket here, this means the 25 is included. So in the first bin is 0 to 25, and you see that this is that is bracket, so which means 0 is not included. So this first range is only from 1 until 25. And then the second one, do you see that 25 and it has a bracket? So that means 25 is not included. So this particular interval is actually starting from 26 until 50. So square bracket means it is included. Bracket means this value is not included. So again, you see that as a bracket for 50, which means 50 is not included. Starting from 51 until 75, and you see the square bracket, it means 75 is included. Here you see bracket, which means 75 is not included. So it's starting from 76, and 100 is included because you see the square bracket. So this is how to read this bracket and also the square bracket. That's what actually this means. So you can see there are 4, 1, 2, 3, 4, right? So let me see if we are going to look at, if we want to see how much here, this might be difficult for us. Here what we can actually see is, we can see in broad, we have actually 4 categories, right? This is 1, this is 2, this is 3, this is 4. But then how do we know in each category what are the, in each categories, just hold on. Okay, so we want to know in each category, how many numbers fall under each category. This is the binning that we have actually created, the intervals, but how many numbers are there in each category? So for that, so we can use my category. So my category, if we view, let me just try this one. If we view the categories, do we, yeah, we can, if we just use, if we want to view the categories, the interval index category, these are the intervals, which is almost the same as previous one. But because previous one, when we try my category, it also shows all the numbers within the category, and also it shows the interval. But let's say if you just want to view the intervals, then you can also use my category dot categories, and it will only show the categories. But this one we have already know. But let's say if we want to know in each category how many numbers are there. So here we can actually use another Panda library, which is known as value counts. So this value counts will able to let us know what are the, under each category, in each interval, how many numbers are there which falls under that particular category. So for that, we're going to use Panda library, and this is known as value underscore counts. So it comes with an S. then you pass my category. So do you see? Now it gives you the range. From 50 to 75, there are 7 numbers which falls within this range. Sorry, not 50 to 75. It's supposed to be 51 to 75. There are seven numbers that fall within this range. From 1 until 25, there are 5 numbers that fall into this range. From 26 to 50, there are 5 numbers that fall into this range. From 76 to 100, there are 3 that falls into this range. So if you add them up, of course, you get back 20 numbers, right? So this is on value counts. So this enables us to find out how many values fall under each category. This is what we have already explained earlier. So let's say we put it down. Instead of numbers, earlier we have seen this. Right now we are actually seeing in terms of numbers, right? How many numbers that are there. So we can actually assign labels to it. We can actually give some meaningful names for each bin. Instead of using numbers, we can actually this one, instead of numbers, we can actually define it by meaningful labels or meaningful names. So how can we actually do that? So we are interested in giving meaningful names to the bins, So how can we actually do that? So now, again, like how we did earlier, we need to define the bin. Let's say we call this as the bin names, just like how we did earlier. So maybe we can put this as poor, below average, then this one could be average, because we only have 4 bins, right? So we're going to just assign 4 and good. So once we have established the bin names, we're going to use the same cut function, pd cut, and remember that it actually requires the readings, the data, and the bins. So these bins will actually help to assign, to let it know what is the range, the actual range. And of course, now we're going to add another one, which is the label. We're going to label each bin by using the bin names. So when we do this, so now you can actually see that you actually have, now it actually categorizes based on the proper label. So is that okay? So this is how we can actually do that. So now instead of values, you can straight away categorize. So let's say if we want to look at, let's see, if we do the pd dot value counts, so let's say the same thing that we want to actually view. So let's actually do this, my category 2. That's why it's my category 1. So we need to define this. So now we're going to pass this value to my category 2. So then you now will be able to see how many students belong in the poor category, how many are in the average and below average and also good. So in this way, we can actually use the label to label. So the pandas library also provide another function which is known as qcut, which means quantiles. Earlier we have seen the quantiles, right? So it automatically divides the data into quantiles. So qcut ensures that the number of occurrence for each bin is equal, but the ranges of each bin, they actually may vary. So which means now the qcut, what it does is it actually divides the data into quantiles. So which means, and it ensures that the number of occurrence for each bin is equal. So that means for each bin, let's say if there are 4 bins, it'll make sure that the number of occurrence in every bin is the same, but the range for each bin, it will vary. So if we are looking at, let's say we're going to do the same thing, pd dot q cut, quantile cut. So this one requires, of course, the data set readings, and we're going to divide it into 4. So how many quantiles do you want? If you put 4, then it'll give 4. So now it actually divides into 4. You can see there are 4 quantiles. It divides into 4. But then in order for us to actually check, now you'll see what I mean by when it actually divides the data under each bin, the occurrence of it will be equal. So we can actually use that PD value counts. So we can use the PD value counts, and we are going to use this PD. We're going to use this, not cut, but Q quantile cut, and we're going to pass the readings and 4. So now we'll be able to see that the occurrence, we have totally of 20 numbers, right? The occurrence in every bin is the same, so it divides the same. But notice that the range is different. The range is not the same. Earlier the bins used to be the same and the value is different. When you use quantile cut, it ensures that each bin occurrence are the same, but the range may vary. So these are some of the things that we can actually use for us to do the discretization and also binning. So next we are going to look at aggregating data. So of course this aggregation means we are interested in grouping a data together into a list or any other data structure, and we can actually aggregate them, and you can actually use statistical functions as mean, median, count, or sum to combine several rows together. So of course whenever you have certain groupings, it makes it easier for you to actually analyze. So let us actually try to create a data frame and for us to understand the concept of grouping or aggregation. So let us look at the first example. So let us create a data frame, a data frame that we are going to create a dictionary object first. So let's create the first one is the color key, and we're going to create a list of color, which is, let's put any random color, blue, white, red. We can also put red 2 times, and let us just keep as how many objects? 5 objects are there. We'll just do that. The second one, we'll put the object key. I'm going to create a list also. So this will be, let's say this will be a ball, for example, and this can be a pen, this can be a pencil, paper. Just randomly putting 5 stationaries and maybe a mug. Okay, so then we create another key, which is the price. So we're going to create a list for the price. So maybe this is 1 ringgit 20 cent. This is 1 ringgit. This is maybe 60 cents. This is maybe 90 cents. We have 1, 2, 3, 4, maybe 170. 1 ringgit 70 cents. So this is the data dictionary. So we're going to create my frame, and you're going to use the data frame constructor to create a data frame. So we're going to pass the dictionary, and we can actually view your frame. So we have created a data frame here, which has the color, object, and also the price. So purposely, you can actually see that the color, we have two colors, right? For white and also red. So now, if we want to group this data, let's say we are looking at the data price. So let's say if we are trying to group the this data based on the color. So of course here the numeric thing that we are later on maybe interested is, for example, the price. What are the price of all the blue color items? What are the price of all the white color items? What are the price of all the red color items in white? So in that sense, if we want to group them based on color, so we can actually type the following. So let's create a group, my group. So this my group is actually from my frame. And for my frame, we are actually, which column that we are interested in is maybe price. And what we're going to do is we are going to group this group by. So this is the keyword, group by. So we're going to group the prices based on the color. So then if you look at my group, so what this will do is when you do this, my group, you're getting my group variable, and you're actually taking the my frame price attribute and you're trying to group it by color, based on color. So the my group will capture the number of groups. So let's see if we put my group, what happened. Okay, sorry. You have to use my group, you have to use groups. Then you'll be able to see. Yeah. So now you can actually see it actually now groups in terms of color. So blue color is actually item number 0, red is 2 and 3. Is it correct? So you can see it actually groups. Blue is 0, red is 2 and 3, white is 1 and 4. So it groups. So it actually shows you the index, but it groups all the blue together, all the blue items together, all the red items together, and all the white items together. So of course you may ask what happened to the price. So we have not done any manipulation on the price yet. So we will be doing after this. So you can actually see that we actually get 3 distinct groups. So these groups are blue group, red, and also white. And we get this by using this group by. We use the function group by to group them, but we use the attribute groups to view the groups. So now we can actually use this my group to find the average value. Remember that we were interested in the price, right? So what it does now is it group all the blue. So the price of the blue is here. Red, the price of the reds. The price of this is not the price of the red. This is just the index. But what I'm trying to tell is how it actually groups. So the white is index 1 and index 4, but the white prices are there. So now it's all captured under my groups, right? My group. So all the prices are grouped based on color. I think this would be a much more easier way for you to understand. All the prices are grouped together based on color. So when we use my group, this is your the new data frame, and you're using the attribute groups, it shows you the groups, which is correct. So now we can actually use, we can actually find the average value and sum of the numeric feature. So let's say if you want to find, remember that my group is actually grouped based on the price. So let's say now if we want to find the mean value. So now you see it's all grouped based on color. So the group, what is the average price, red what is the average price, white what is the average price. Likewise, you can also do my group. You can also find the sum of all the prices based on color. So in this way, based on the groupings, you are able to find the mean and also the sum. So yeah, maybe we will keep mean here. Keep the sum here. So you can see two distinct values that are there. This is a sum. So it actually adds up all the value under each category. Now, of course, we can also perform the aggregation using more than one column. So earlier we only grouped by color, but now we can also group by color and also object. So this is known as hierarchical grouping. So how we can actually do that is the same as before. So let's create another data frame, my group 2. So equals to my frame. We're just going to extract out the price. Sorry, not extract out price. We're going to use the price, and we are going to group by, and here we need to provide the argument. So earlier we actually typed my frame, and then we use the colors, right? Not colors, color. My frame color, correct? Oh, yeah, this is what earlier what we did. So now we can actually also put a comma and add my frame. Let's say now is object. Okay, sorry. So when we do this, because we are giving two inputs here, we also need to use the square bracket. Sorry, square bracket, because we have two arguments, right? So now when we actually do this, this is my group 2. So let's try to view my groups 2, the groups. Let's try to view the groups. So now you can see it actually groups by color and object together, blue ball. So there's only one blue ball combination, so that's why it's there. But you can see red, there are two combinations, right? So one is red paper, another one is red pencil. White also there's two combinations, right? White mug, white pen. So you can see how able to perform the grouping. So now let us create another new data frame. It's known as my frame 2, same as my frame, but then we'll add another additional data entry. We're going to add, sorry, this is some minor typo here. A red pencil 0.5, and we're going to add another index. Okay, so we're going to create my frame 2. So my frame 2, we're going to equate it as my frame, so that my frame 2 gets exactly right. So sorry, I accidentally run in. So if you type my frame 2, you'll get exactly the same as my frame. But what we're going to do now, but what we're going to do is we are going to add. So my frame 2, add location. So we're going to add location index 5. So we are adding, previously we only have index 4, right? So what we're going to add at index 5, we are actually going to add red pencil, and the price, price is 80 cents. So now again we try to view my frame 2. So now you can see that we have already added. So now let us try to group. So now we have additional rate. There are 3 rates. And you can see red pencils, there are 2. So let's try to actually group them by color as well as the object. So let us see. So this is my groups. 2 equals to my frame 2, and we are actually looking at the price, and we are going to group by. So we are going to provide two input. So one will be my frame 2, don't forget the 2, my frame 2 we're going to group by color, and then my frame 2 we're going to group by object. So now let us see my group 2, the groups that have been formed. So now you can actually see blue ball, that's one, red paper, red pencil, white mug, white mug. So you might have noticed that under red pencil, the grouping, there are two entries, right? One is at index 2 and one is at index 5. So each time you only see one index, that means there's only one item. This is only one item. Here you can see two index, so there's two items. Here is one index or one item. This is one index or one item. So likewise, we can also find what are the average and also the sum of the prices for each group. So we can put my group 2, we can actually find what is the mean. The blue ball is this one, a red paper, this is the price, red pencil, this is the price, white mug, this is the average price, white pen, this is the average price. So likewise, we can also do to find out what is the my group 2, the sum for each category based on the object and also the color. So you can see blue ball is this much, red paper, red pencil, white mark, white pen. So this is how we can actually perform the data aggregation. So I think we'll stop here. The next topic is on selection of data.